Hey y'all. In one of my more recent videos, I made the claim that if I have any two factors, A and B, and they multiply to make 0, it must be true that A equals 0 or B equals 0. I made that claim. And I asked you guys to just think about it for a bit and kind of convince yourself that it was true. Well, now I'd like to prove to you that it's true. And I think that this one's a fun one because it really shows you some of the ways in which proof works in mathematics. So this is going to be what we call a proof by contradiction. Contradiction. The idea of a proof by contradiction is that you make an assumption. That this is not true, right? So we're going to assume that it is not true that A equals 0 or B equals 0. So we're going to assume that A does not equal 0 and B does not equal 0, right? We're assuming that. Now, if A does not equal 0 and B does not equal 0, that provides us with some cases, and this is a common strategy in math as well. When you're proving things, you just set up the various cases that you could exist in. One case is that A. So here's going to be case 1, where they are both positive. So A is greater than 0 and B is greater than 0. Case 2 would be that they're both negative. A is less than 0 and B is less than 0. And then case 3 would be that they are one of them is positive, so A could be greater than 0, and one of them is negative, B is less than 0. Now, interesting thing, you don't need to actually switch this because A and B are just variables. It doesn't matter which one's greater than 0, which one's less than 0. All that matters is that one of them is positive and one of them is negative. Now, let's look at case 1. If I multiply two positive numbers together, you guys know what you get? You get another positive number, right? Any two positive numbers multiplied makes a positive. What about when I multiply two negative numbers? When I multiply two negative numbers together, I actually also get a positive number again, remember? So this is where AB would be greater than 0. And if I multiply a positive with a negative number, I get a negative. So I know that AB would be less than 0 in this case. So in the first case where they're both positive, their product would be positive as well. In the case where they're both negative, their product would be positive. In the case where one's positive, one's negative, their product would be negative. The key idea here is that in all three of the cases, AB does not equal 0, right? But that contradicts the original concept of this proof, right? We said that AB multiplied to make 0, and then we set out this assumption that A does not equal 0 and B does not equal 0. And then we proved that that could not be possible. So, therefore, let me continue my proof down here. I'm going to zoom out a little bit. Therefore, that's what this 3 dots here means. In math, these 3 dots mean therefore. Therefore, if AB equals 0, then A equals 0 or B equals 0. And that is my proof. This little filled in box is a thing that we do in math when we're proving things, which sort of means like my proof is that which was set out to be proven is done. It's like I'm done with my proof. So this is a pretty easy, but let's be real. Proofing is not easy, right? Proofing is hard. But I think that this is a proof that's really approachable and kind of can get you warmed up in seeing a little bit of the cool ways in which math gets applied beyond just our high school curriculum.